So here is T-Watt G galvanometer, in which this rheostat, this is ammeter, and this is battery eliminator, and this is key, and this is reversing key. So this is the T-Watt galvanometer, in which the needle is there in between, and when I reverse this key, I can get the deflection like this, and again if I reverse this key, needle will again deflect in the opposite manner. So along with this I can do give two different values. Okay, so along with left movement, current carrying coil give you another magnetic field value. Same is with the right hand side. This is your whole experiment. Okay, now I will show you its observational table. So beta, that was movement from 0 point to the left hand side, and now I am going to take the distance along the right hand side. So right hand side I have marked here 3 centimeter. So along with 3 centimeters I will show you the deflection. So as this coil is moving, as first of all it is at this point, when I just deflect and when I just reverse the key, along with that key there is motion in the coil, and this is your second reading. So first this was your reading 25, and then when I move it, then when I move this reversing key, then I can get another value. So these are the two values for the right hand side also. Okay, one is single value and another is deflected value. So these readings we can take with the reversing key with the help of reversing key. Okay, and tan the values which we get, along with that I can equate it in the term of theta, mean of that values, first one value and reversing value, and mean of that values are known as theta, and tan theta we can calculate. Okay, so along with that graphical representation must be there. Thank you. Distance from center X, that is on the left hand side and on the right hand side. Along with that I have two deflections which I have shown you in the needle, direct and reverse. So mean of direct and reverse will be the theta, and that theta if I trace for the tangent value, that is tan theta. And here at the bottom I trace a graphical representation where on the x-axis I have distance of the coil for left hand side and for the right hand side, and this y-axis is for the magnetic field. So you can trace the graphical representation like this for left hand side and for right hand side. So this was your whole experiment to measure the variation of magnetic field along with axis of circular coil. So deflection reading is important one, which you have to take on the left side with the direct deflection, and for the right hand side for direct deflection. Along with that, when I reverse the key, then I can get the reverse deflection value also. Thank you.